Good morning, good students. Today we're going to look at how to solve exponential equations. Our last lesson in this section, the next one will be solving them graphically, but today we're going to do them algebraically, solving for x. So let's get started. The key to solving these breaks down to this. When an exponential equation has the same base, and notice there we said it has the same base, on each side of an equation, then the exponents must be equal. In other words, if b is bigger than 0 and b is not 1, if b to the x equals b to the y, then x equals y. So we can use this to solve equations. For example, the first thing we want to do is we want to rewrite each equation using the same base. And now, since the bases are equal, then the exponents must be equal, so then we can solve for x. Now, the key here again is, in other words, if I have 2 to the third power equals 2 to the x, notice the 2's are the same, I know then that 3 must equal x. If the bases are equal, then the exponents are equal. However, suppose I had this. Suppose I had 4 squared equals 2 to the x. Well, notice those are not the same. So I can't say 2 equals x. However, I could change the 4. Because 4 equals 2 squared, I could rewrite this as 2 squared squared equals 2 to the x. And then I solve that. When you take the power of a power, you multiply. So I get 2 to the fourth equals 2 to the x. And now, same base, so the exponents must be the same. So that's the key thing in this problem. Generally, if you're just trying to make sure you get the bases to be the same, and then if they're the same, then the exponents are the same. In our first problem, we're trying to find what's the value of x so that 3 to the x power equals 81. Or in other words, how many factors of 3, 3 times 3 times 3 times 3 does it take to get to 81? There's multiple ways to do that. One is to start kind of factoring it. 81 is 9 times 9. I need to get 3's. Well, each 9 is 3 times 3, so I see that that's 3 times 3 times 3 times 3. Kind of like doing that factor tree again. So I see that that's actually 3 to the fourth power. And now, because the bases are the same, they both have a base of 3, the exponents must be the same, so I can write x equals 4, and that's my answer. In problem 2, once again, we have 5 to the x minus 2 power equals 65. So to get them to be the same base, I need to figure out how many factors of 5 make 625. Now, I happen to know that 25 squared is 625. So that's going to be 5 times 5 or times 5 times 5. So that's 5 to the fourth power. If you don't know that, one way to do it is what I kind of call, upside down division. If I take 625 and I divide it by 5, I get 125. Now, how many 5s go into that? I get a 25. If I put 5 into that, I get a 5, and you can see 1, 2, 3, 4 5s. So if you don't recognize factors right away, you can do that. Now notice, since the bases are the same here, 5 to the x minus 2 equals 5 to the fourth, I can then say that the exponents are equal, so I can write x minus 2 equals 4. Don't get trapped here and automatically saying, oh, x equals 4. No, x minus 2 equals 4. So now we'll solve the simple one-step equation, add 2 to both sides, and we find out that x equals 6. You see, 6 minus 2 is 4, and 5 to the fourth is 625. Now, problem 3 throws us a little bit of a curve. If we had this problem over here, let's suppose I had 4 to the x equals 16. We go, okay, I know what that is. 4 to the x is 4 squared, 4 times 4. So then that would mean that I could say, okay, x equals 2. But I don't have 16, I have 1 over 16. Now there's a little bit of help there. Here I have to remember about negative exponents. Remember that any number to the negative number is 1 over a to the n. Okay, so that means if I have 1 over 16, and that happens to be 1 over 4 squared, what that actually equals is 4 to the minus 2. All right, you see that connection right there? 1 over 16 is 4 squared, but it's divided by 4 squared, so that's 4 over minus 2. And that's the key to solving this problem. Because I can see here 4 to the x is 1 over 4 times 4, or 1 over 4 squared. But 1 divided by 4 squared can be written as a negative exponent, 4 to the minus 2. Now the bases are the same, 4 and 4. So I can assume now that the exponents are the same. And my answer is x equals minus 2. In problem 4, once again, we have a fraction. And we have a 2 and an 8. And we know that 8 is factors of 2, but it's going to be in the bottom. Let's break this out first. Notice that 8 is 2 times 2 times 2. So this is 1 over 2 cubed. Now again, we remember that 1 over 2 cubed is going to be 2 to the minus 3. The negative means I take the reciprocal and make the exponent positive. So we're working backwards here. So that's going to be 2 to the minus 3. So since the bases are the same now, they're both 2, my answer is going to be x equals minus 3. Problem 5 is basically the same, except they switched the equation around. They put the fraction on the left side instead of the right side, but we're still working with the same problem. We just have the x on the right instead of the left. So I got to figure out how many 6's go into 216. The answer is 6 times 6 is 36, and 6 times 36 is 6. If you weren't sure about that, you could sit here and go, okay, what's 216 into 6? Well, that goes in 3 times, with 3 left over, so it goes into that 6 times. And now I could put a 6 into here and get 6, so I have 1, 2, 3 6's, make 216. All right. Now, following like we did before, 1 over 6 times 6 times 6 is 1 over 6 cubed. But 1 over 6 cubed is 6 to the minus 3. And now we can, because the bases are both 6, we can set the exponents equal to each other, and we have x equals minus 3. In number 6, we kind of have a combination of two previous problems. First of all, our equation is not just 2 to the x, it's 2 to the x plus 4. But we also have a fraction here to work with. First thing we're going to have to figure out is how many 2's go into 1024. All right? So one way to work it is to go, okay, this is 1 times 32 times 32. But most of us don't know that right offhand. What you might have had to do another way, if I did this, then I know that this is 2 to the 5 times 2 to the 5, or 2 to the 10. But if you didn't recognize it's 32 times 32, don't be afraid. I could have come back here and just started dividing into 2. So that's 512. 2 goes into that, 256. 2 goes into that, 128. 2 goes into that, 64. 2 goes into that, 32. 2 goes into that, 16. 16 is 8. 2 into 8 is 4. 2 into that is 2. And you count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is what we got over here. So 1024 is 2 to the 10th power. But it's 1 divided by, so once again, we need to change that to a negative. So we have 2 to the x plus 4 equals 2 to the minus 10. Now, because we have the bases equal, right, our bases are both 2, we can assume then that the exponents are also equal. So we can write x plus 4 equals minus 10, and now we solve a simple one-step equation. Subtract 4 from both sides, and we find that x equals negative 14. All right, number 7 is fairly simple. We just need to find out how many 5's go into 125. So if I divide 5 into 125, I get 25. So that's 5 times 25. And then 25 is 5 times 5. So notice that 125 is 5 to the 3rd power. The bases are the same. So let's let the exponents be the same. 1 plus x equals 3. So let's subtract 1 from both sides. And x equals 2. Now 8 and 9 are put together because they offer a unique situation. We've seen this in linear equations before, and we shouldn't be surprised to see it in exponential. when I do this, I recognize that 7 goes into 343 49 times. And then 49 is 7 times 7. So this is going to be 7 to the 3x equals 7/3 to the x. And notice that when you take the power of a power here, remember the rule for that is a to the n to the m power is a to the n times m. When you're taking the power of the power, you multiply. So what we end up with is that 7 to the 3x equals 7 to the 3x. The x bases are the same, so the x must be the same. If I divide by 3, I end up with 1 equals 1. 3x then 3x. And notice, when is 1 going to equal 1? All the time. In other words, what we have here, like we had in linear equations, this is an identity, which means that no matter what number you put in for x, that equation is going to be true. Now, you know what's going to happen in 9 since this is an identity, but let's go ahead anyway. Negative 32 is negative 4 times 8, or negative 2 times negative 2 times 8, negative 2 to the 5th power. All right? So our problem here is the bases are not the same. And there's nothing that I can do to make a 2 a minus 2. No matter what value you put in, minus 2, it's just simply not the same. There is no solution for this equation. Negative 2x is never going to equal minus 2. And of course, the obvious reason is no matter how many times you multiply, 2 times 2 is 4. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. Notice they're all positive numbers. Keep multiplying by 2. You're never going to get a negative number. And that's why this is going to be no solution. In the last two problems, we're actually going to solve some word problems, some real life problems. This one talks about the number of bacteria in a culture after X days, and you have the formula there. It says after X day, the culture grows. It grows exponentially. I mean, we're all experiencing what exponential things are now with the coronavirus. It's growing exponentially. They've said that all of California was started by 8 people who came, got off cruise ships from Asia. And those 8 people have resulted in all the people in California who had the virus. It's grown exponentially. Well, there's the model. And we want to know how many days will it be until there's 729 bacteria. So what we're simply going to do here is set them equal to each other. So I have, when does 3 to the x plus 1 equals 729? Now at this point, I'm going to have to start figuring out how many 3's go in here. So 3 goes into that. Let's see, 2 times, carry the 1, 43. 3 goes into that, 81. 3 goes into 81, 27. 3 goes into 27, 9. 3 goes into 9, 3. 1, 2, 3, 4, 5, 6. So there's going to be 3 times 3 times 3, 6 times will give me 729. Or you might have known that 27 times 27, I didn't write offhand. But the key point is that we ended up with 6 factors of 3. Now, since the bases are the same, we can set the exponents to the same and solve the simple one-step equation. Subtract 1 from both sides, and x equals 5. Okay? So in 5 days, the bacteria will grow to 729. In the last problem, it says that when you fold a tablecloth, each time you fold it in half, you double the size. So Rx, the region, equals 2 to the x power. How many folds do you need to make 128? In other words, if you take one tablecloth and fold it in half, you now have 2 sections. Fold it again, and now you have 4 sections. So we're going to set the equation equal to find out how many will make it 128. So 2 to the x equals 128. Again, we need to find out how many factors of 2. I go back to my trusty upside down division. That's 64. That's 32. 2 into 16 is 8. 2 into 8 is 4. 2 and a 4 is 2. 1, 2, 3, 4, 5, 6, 7. So in our case here, 8 times 16. Key thing here is we recognize that it's 2 to the 7th. So the exponents, the bases are the same. So the exponents must be, and that means it's going to be 7 folds will end up with 128 regions. All right. Have a great day.